of a lightning bolt is about 10,000 amps. Obviously, it matters from lightning bolt to the next. How much electric field is needed to cause a spark or a lightning bolt? We could call that the electric field critical. So the electric field that causes this to occur, and that's about 3 million volts per meter. Jervell is correct, that the units of electric field are newtons per coulomb, but also an alternate unit of electric field is volt per meter. Those are both correct units of electric field. Sometimes it's more useful to think in terms of volts per meter. So for example, if I have a 20 volt difference between the floor and the ceiling of this room. So suppose I connect a 20 volt battery and touch one end to the ceiling metal and one end to the floor. There's maybe, 3 meters between the floor and the ceiling here. The electric field that would result from that would be 20 volts per 3 meters, or about 6 volts per meter. So every meter I go up would be a difference of 6 volts, because I got to go from 0 up to 20. So electric field is also a measurement of volts per meter. Suppose my clouds are maybe 1,000 meters up. So if I need 3 million volts per meter to cause a lightning strike, and if my clouds are 1,000 meters up, what would be the voltage difference between the Earth and the clouds and the needed to have a lightning strike?
3,000 million?
Yes. Because it's 3 million volts per meter. If that's a 1,000 meter difference, I would have to have a voltage of 3,000 million volts. Okay. This is assuming that it's all uniform. How much power would be found in a lightning bolt?
A lot.
Or absorbed?
3,000.
What would I do to figure out the power?
3,000 times 10,000?
Current times voltage. This is a good
3,000
review question.
million
Power,
times 10,000.
current times voltage.
I don't even know what that
3,000 million. Let's now write that a little
That's 3
differently.
million.
That would be 3 times 10 to the 9th volts. This is 1 times 10 to the 4th amps. So the power for a lightning bolt would be what? Multiplying numbers with, yeah, 3 times 10 to the 13th watts. Okay? So 3 times 10 to the 13th watts. How much energy would be absorbed by this lightning bolt? What's the relationship between energy and power?
Times time.
Isn't power joule per second and then energy is just straight joules?
Powers, or a watt is a joule per second, we say it that way. That might help us a little bit. So if you can remember that, might figure what that relationship could be, right? Equals power. So power equals work over time. Now technically it's a derivative. Power is dW dt, the rate of change of that. But if I assume I have a steady power and I want to figure out how much energy or how much work is done, to figure out the energy, I would take the power times the time. So I looked up online, what's the duration of a lightning bolt? If I told you it was a millionth of a second, I think you'd be surprised, because I'm not sure I would be able to see a lightning bolt ever if it only lasted for a millionth of a second. So you might not be surprised to know that a lightning bolt, the time duration of a lightning bolt is about 50 milliseconds. So 50 milliseconds is 0.05 seconds. How much energy going to say the word transmit. It's not really transmitted. It's being absorbed by the air. So how much energy is absorbed for one lightning bolt? So the energy would be the power, which is 3 times 10 to the 13th watts, times the time, which is 0.05 seconds, which would be, that would be 0.15 times 10 to the 13th, which is 1.5 times 10 to the 12th. What are the units on energy?
Joules.
Joules, yep. So we've got 1.5 times 10 to the 12th joules. How much energy is stored in your gas tank in your car? Any idea? I mean, it looks like a big number, right? 1.5 times 10 to
50,000?
the 12th joules. So let's get a comparison. If this is only 1/10 of your gas tank, and not quite so impressive. If it's, let's try to get a sense of how much energy this is. So 1 gallon of gasoline stores 100 million joules. So 1 gallon of gasoline is approximately 10 to the 8th joules. Well, for me, it's a handy number to have. I think when you're trying to compare energy, is it a lot, is it little? I think knowing how much energy is stored in a gallon of gasoline is a handy comparison point. So 1 gallon of gasoline stores 100 million joules, which is 10 to the 8th joules. Your gas tank has roughly how many gallons in it?
Six.
10. All right, 10. So 10 gallons of gas then will store 10 to the 9th joules. This is 10 to the 12th joules. So it seems like a lightning bolt would have the energy of about 1,000 tanks of gas. Now these are very rough numbers. I'm not an expert in atmospherics and all this other stuff. But it gives us a sense for how much energy is stored or would be absorbed by a lightning bolt, and reviews a relationship between power, current, and voltage, and power and energy. And I've introduced a new idea which I need to use later anyway. This idea that there is such a thing as a critical electric field. I cannot just keep increasing voltage between, say, 2 plates and think I'll be able to maintain that voltage difference. If I have a very large difference in voltage between 2 objects, eventually there will be a spark between the 2. The air will not be able to prevent current from flowing from one spot to the other. It's good to be aware of that. Of course it happens with lightning, but it also can happen just for yourself in the doorknob. You might sometimes see a little spark, and that problem of getting a spark is one of the main reasons we can't use a capacitor, which we'll be talking about more today, why we can't use a capacitor to store energy for a car. You technically can, and we'll calculate how big that capacitor will need to be in a moment. Okay, so we'll come back to that later, but first I wanted to connect some of our ideas to the everyday phenomenon of lightning, and then we'll use some of these ideas in a moment. James.
So if a lightning bolt hit a gas station, would that not be a good thing?
That would not be a good thing. So, yeah, a gas station probably would store, 1,000 tanks of gas, just roughly, so it would kind of double its power.